You've probably heard love described as a modern invention, something that came from poetry, from Hollywood, from a greeting card industry selling you a feeling. But strip away the roses and the dating apps and ask a harder question. Does your capacity for that feeling go back further than culture itself? The honest answer, pieced together from three completely different kinds of evidence, is probably yes. But it's worth being careful about what each piece actually proves, because they don't all prove the same thing. Start with a skeleton nicknamed Ardi. She's 4.4 million years old, a member of the species Ardipithecus ramidus, discovered in Ethiopia. Anthropologist C. Owen Lovejoy looked at her teeth and noticed something strange. In most primates, males carry large, dagger-like canine teeth, weapons for fighting other males over access to females. Ardi's species didn't have that. The size gap between male and female canines had nearly disappeared. Lovejoy's hypothesis is that fewer violent contests over mates meant something else was happening instead. Males investing in one partner rather than fighting for many, made possible by bipedal walking freeing the hands to carry food back to her. But that hypothesis rests on one signal, and one signal isn't proof. Primatologist Franz de Waal has pointed out that reduced canines also show up in bonobos, a species that is famously not monogamous. Other researchers call Lovejoy's reconstruction speculative, built more on inference than direct evidence. So hold this piece loosely. A tooth pattern alone can't tell you what was happening in someone's heart 4.4 million years ago. At best, it suggests the physical conditions that make pair bonding possible were already in place, millions of years before you'd expect. Now jump forward to something with far less ambiguity, hard genetic data. At a site in Russia called Sungir, roughly 34,000 years old, 4 individuals were buried together, wrapped in an extraordinary number of beads, clearly the product of enormous ritual and effort. In 2017, researchers led by Esk Willersleff sequenced their genomes, expecting to find a tight family unit. Instead, the individuals were, at most, second cousins. That's not evidence of romantic feeling itself. It's evidence of something more specific, that these humans had built social systems, likely involving contact and exchange between separate bands, specifically so that partners could be found outside their own small group. What it proves is opportunity, not emotion. It shows Upper Paleolithic humans had already organized their world to make pair bonds with near strangers possible and normal, the kind of structural condition romantic attachment needs in order to happen at all, whether or not you can prove what any individual person felt. So you have a possible physical readiness 4.4 million years ago, and a proven social structure for it 34,000 years ago. What about the feeling itself? Is there any evidence for that? For this, look inside the brain directly. In 2005, biological anthropologist Helen Fisher, working with Arthur Aaron and Lucy Brown, scanned the brains of people who described themselves as intensely in love and found spikes of activity in dopamine-rich reward regions, the same circuitry involved in other powerful motivational drives. Fisher's framework describes love as 3 overlapping systems: lust, which broadens the search for partners; romantic attraction, which narrows it to one specific person; and attachment, which sustains the bond long enough to raise a child. Across a survey of 166 societies worldwide, Fisher's team found clear evidence of that specific, obsessive, can't stop thinking about them feeling in 147 of them. This is the piece that actually speaks to the feeling, not just the biology or the social arrangement around it. And underneath even that feeling sits older chemistry. Though here, the comparison needs a clear caveat of its own. Researchers Sue Carter and Larry Young built much of what's known about the biology of pair bonding by studying prairie voles, one of the few mammals that mates for life. Carter's team found that oxytocin, already known for its role in childbirth and maternal bonding, was essential for a vole to form a lasting attachment to its partner. A related hormone, vasopressin, plays a similar role in males. Rodent brains are far simpler than human ones, and a vole's bond is not the same rich experience as human romantic love. Nobody is claiming a vole falls in love the way a person does. What this research shows is narrower and more defensible. Humans have the same oxytocin and vasopressin systems, and in humans those hormones appear to support the capacity to bond, the biological readiness underneath the feeling. while what that bond actually becomes is shaped by thought, memory, culture, and choice. Biology hands you the wiring. It doesn't hand you the relationship. So here's what the full picture actually looks like. And it's not one continuous timeline proving a single thing. It's three separate kinds of evidence, from three separate fields, converging on the same question from different angles. The fossil record offers one contested clue about when pair bonding first became physically possible. The genetic record from Sungir proves humans were already engineering the social conditions for it 34,000 years ago. And neuroscience shows the feeling itself runs on ancient, dopamine-driven circuitry shared in part with a small grassland rodent. None of these pieces alone proves ancient humans fell in love the way you understand it. Together, they suggest the readiness for it. The anatomy, the social scaffolding, and the brain chemistry was already assembling itself long before anyone had a word for love at all.